The series is structured around some cross-cutting questions that we hope can generate new perspectives on the nature and interrelationships of different elements of the overall housing system, which, as we all know only too well, limits choices for far too many people, imposes very heavy, often unsustainable cost burdens on some, and leaves many people without shelter altogether. Our current housing supply is both inadequate and a bad fit for the dimensions of our collective need. The Housing System series is not specifically about affordable housing or homelessness or public housing or the luxury market or middle-class homeowners, nor is it about specific design strategies or financing models or policy innovations, although it has touched and will touch tonight on all those things. It's called the housing system to emphasize that all aspects of the ways that we finance, design, build, maintain, and inhabit housing for all income levels are interconnected, dynamic, and mutually affecting. In earlier programs, we've learned about building and neighborhood maintenance, about small dwelling units and their history, viability, costs, and possible impacts, about various ways the city, market-driven developers, and the nonprofit sector are approaching the potential promise offered by a variety of types of shared housing. And last week about how Los Angeles and Minneapolis have changed their zoning codes to allow the insertion of a much more variegated mix of housing types in low-density neighborhoods. Our final event in the series will take place on Monday, June 10th. And please note that this program on the 10th will begin at 4 o'clock in the afternoon here in this auditorium. The program is a real departure and experiment in both format and content, and I think it's going to be extremely interesting. The program will take the form of a conversation between Roseanne Haggerty, the founder of Common Ground Community and Community Solutions, both of which are organizations that have been path-breaking leaders in working to end homelessness, and Donald Berwick, who's had a formidable career in healthcare reform, and among many other positions, was the vice chair of the U.S. Preventive Services Task Force, which looked at how to reconceive medical care to focus on promoting health rather than reacting to illness. They'll be talking about how to conceptualize and enact systemic change in complicated systems. Before introducing tonight's speakers, I want to say a big thank you to Emily Schmidt, who has been absolutely critical in helping conceptualize and organize this series, and all of the Architectural League staff for essential help in making these events happen. Tonight we're going to talk about technology, about materials and methods. At various times in the history of housing, new technologies have been invested with the hope that they could somehow reduce the cost of construction enough to make housing affordable across the income spectrum without subsidy. That goal seems to have always been beyond our reach, and housing construction, like all construction, has been stubbornly resistant to significant change. So there remain very substantial inefficiencies in traditional construction and very substantial environmental impacts of commonly used materials, including concrete and steel, that urgently need to be addressed both for cost and carbon reduction reasons. Tonight, we're going to hear from 3 people who are working at the forward edge of research and implementation of new approaches to building design, the organization of supply chains and construction, and radical reconsideration of the properties and possibilities of materials. Longer biographies are in your printed program, so I'll be brief. Our first speaker is John Cerone. John is an associate principal at Shop Architects, where he leads the virtual design and construction teams, and among other responsibilities, leads the firm's work with Dassault Systems as part of a transdisciplinary group that includes Boeing and Tesla. Craig Curtis, our second speaker, is president of Katerra Architecture, the design division of the vertically integrated design and construction company Katerra, where he leads a large team of architects and designers. Craig joined Katerra from Miller Hull, the Seattle architecture firm where he was a partner for several decades. Sheila Kennedy is principal of Kennedy Violich Architecture in Boston and of MatX, the firm's research division, and she's professor in practice at the School of Architecture at MIT. Marc Norman, our moderator, who will join the presenters on stage for a discussion following the presentations. Teaches in the Urban and Regional Planning program of Taubman College at the University of Michigan and has deep experience in housing development and finance. So please join me in welcoming John Cerone.
Thank you guys for having me and allowing this discussion is very important. I'm looking very much forward to the panel talk. We'll have 15 minutes as soon as I hit go, so there are a lot of slides, there are no words, so we're going to move quickly. SHOP is a New York-based architectural practice. There's no real specific style or move. We work in all sorts of programs and sizes. But this is a process presentation. If you look closely at all of our buildings, there is an embedded R&D element in terms of material, in terms of delivery. And really, the firm itself is very much about understanding complexity, the design complexity, and the delivery of that, what it means to take elements and pieces and components and describe that to the parties involved in the manufacturing or delivery of the building. And just as you would build models, growing up, you never read any instructions. That's the sort of IKEA approach. Piece 32 snaps into piece 31. And industrial design certainly works at the idea of a piece and a part and a sub-assembly, and automotive and aerospace, of course. We do believe that you can manufacture buildings. Great design, great environments, but they can be delivered through a manufactured approach. What it requires is an intimate understanding of, one, of course, it's your design and delivery, the machines and methods, the people you're communicating with. But when you synthesize all of that and don't design that in parallel, you're able to, the modes of communication change. The plan, section, elevation are not the most communicative and effective way to deliver. And as we've, that was a very old project, camera obscura. As we've moved through, we continue to develop methods of communication and whether it's virtual reality, augmented reality, but this model-based approach that the truth really is in the design environment. It's a three-dimensional environment. And we like to know, it's a little faded there, but we like to know the pieces and parts in our buildings, whether we're involved in fabrication or not. When we say that there are 75 different panel types, we mean they're 75. They're not stretched, they're not mirrored, and that there is a nomenclature. We don't know what the manufacturer will call an individual piece, but it is important to understand that they will call it something, and if we build those systems in the design process, we can streamline the move and translation into manufacturing. We have found that to exercise the way we want to, we have had to move out of the AEC toolkit. We've had to expand into softwares and platforms that are not the traditional architectural design realm. So we are, we do leverage aerospace software, and really, this DNA came, the first project, PS1 Pavilion. The only deliverable, this is when computers were hitting Design Studio, and it was very much about making form. The shop approach was that computers are a tool for delivery. The only drawing, construction document, is a one-to-one plotter scale. All of the profiles plotted at a one-to-one and nailed in sections and then erected one slice at a time. That's the only tool needed. And a decade later, if you take that mentality and exponentially our process and tools that we have available to us become more sophisticated, and we're able to handle orders of magnitude more complex delivery mechanisms. So the Barclay Center is our largest sort of proof of concept of prototype scale, where every piece and part is modeled. All the manufacturing deliverables are embedded in templates. There are 950 different mega panels. This is a prefab system. It's built off-site, manufactured off-site, installed in the building, but the design criteria, the model itself, contains all the information, and if it's a little faded, but these are all every design iteration contained all the unrolled panels, which, as the systems develop, as we get information from engineering and from manufacturers, we're able to, address long lead items. How do you order 600 tons of steel while you're in a design process? You have to control all the variables and synthesize design and manufacturing. And to the point, we're able to automate a lot of the fabrication tickets, but the idea of a templated approach, which you'll sort of see in a minute, the idea that you divert or reappropriate energy in building smart systems up front that can be applied instead of having sort of armies of CADs and drafts people. And what we realized, and the sort of takeaway from that, is that it's not about geometry. We can solve the geometry and the CNC and all of that. What it actually, the challenge becomes is logistics. How do you keep track of hundreds of thousands of unique parts? Because the machine doesn't care whether it cuts 12,000 of individual parts or the same part, but you have to track them. So we have our database, and what we realized was low-hanging fruit is we can host a model online. Everyone can log in, and we created that iPhone interface so that you can scan along the factory floor, update, and the process is visualized in real time. There's not sort of monthly reports or weekly reports. Yeah, I mean, Barclays certainly, as a prefab exercise, was in very many ways an experiment. We did not go into that with a defined scope of how it would be delivered, but it was facilitated through these digital tools. And if you sort of look at one individual unit of the 950 different ones, we did it on a terrestrial file-based program. So we're modeling, and you have to keep track. If a piece and part, you have to trace it through your Windows Explorer structure. But if you need information on something, you have to have this very logical ordering system. We've since moved to a cloud-based approach, cloud-based platform where the information is accessible. Everything that has to do with that unit is available instantly, is retrievable immediately, and this relationship and access to information is exponentially faster, which leads to decision making, right? The information itself is not limited now to heavy sort of software platforms. It's all in the cloud. So instant access to the data and metrics, how many pieces, parts, who's made them, web viewers, so that we can work overseas in federation with our collaborators. The project itself actually is the modeling environment, and that is a unique shift. It was quite profound to us when we realized that we're not thinking of a project as a building. We have a portfolio of projects in a platform. Pieces and parts can start to relate to each other across, to the building scale, to the individual bar of a building, to the block, to the trade, to the facade components, down to the individual unitized system, down to the bespoke bracket and piece and part. This ability to move seamlessly through all the scales of the building in real time had a profound impact on how we understand our design process. So Botswana Innovation Hub is something that's near completion, and it's in many ways it's an order of magnitude more complex, or evolution from Barclays, in the sense that we know where to start. You have to analyze it. We need to know how many different pieces, parts, right? So you automate the analysis of your design, and then it's very much in this the idea of a skeleton model. Parametric modeling is not it's not a novel thing anymore in design schools. So it's the idea that it's these lightweight frameworks, but that we can then use those to host complex geometry. That is where the paradigm starts to shift, where the idea that you build these 8 templates account for probably 520 different units. So they're all bespoke units, but you're building the template up front. It's a very simple wireframe, and as you get information from engineering, from the manufacturers, constraints on materiality, you host parametric systems on that pieces, parts, and you instantiate those unique templates. So you spend a lot of time up front building a template that has all of the information, all the fabrication deliverables, everything needed to produce it, and then you automate the production of thousands of units. And of course, our systems for tracking, online sort of databasing, we've built our own tools in-house to facilitate that. And this, this is the information we received from the engineers in Cape Town, South Africa. We asked how far can a member span before you need another connection. And this is not a dig at them. We don't need it on a title block. We don't need a line weights. We need to know that it's 2,200 millimeters until the next strut. And from that, this is the only drawing deliverable we gave. So there's 3,000 units. 1,600 of them are unique, and the only drawing for each one is a IKEA assembly drawing with a bill of materials. Likewise, in what order should we deliver these to you? They sent us this drawing. It's 1, start here, go that way. 2, then we'll move here and we'll go this way. It is the only information we need. We have the CAD, we have the modeling software in terms of schedule performance, and we can simulate quickly with them the iterations of, well, what if we put 2 crews on this? So this idea of creating deliverables, unnecessary deliverables, is that's not good. Of course, we're doing this 99% of the work we're doing from our seats in New York, and so we digitize the building, of course, and we don't release anything for fabrication until it's been vetted, digitally. And it's very much this. The pieces and parts get fabricated in Cape Town, South Africa, packaged up in IKEA kits, essentially, shipped to Botswana and assembled in the parking garage and installed on the building. We know exactly the methods that they're going to use. We know there's not a crane. We know the weight. We know what's reasonable for people to manipulate. And again, all of that was built into the design systems. And yeah, it's near completion, and this was done, obviously very low skill labor, but very precise systems, self-jigging. And just quickly, in terms of material practice, we hadn't done a pavilion in 20 years. We hadn't done one since PS1, and it took a decade for that to sort of manifest into Barclays. And in 2016, we did 2 pavilions. We did one in carbon fiber reinforced plastic, ABS, and 3D printed bamboo. So this is an exercise in autonomous form creation. How few parts can you have? It's dictated by the truck bed, how heavy a piece is to pick and lift. And we did, so that's sort of advanced material looking, and then we did the most traditional material, or one of the most, terracotta. So what can you do with terracotta? You can, control the profile, and then you can cut it. So these experiments, again, these become logistics exercises. How quickly can we set up a system with collaborators that we have great relationships with, understand the tools they're going to use, and execute? Both of these pavilions happen from design to delivery within 3 months. And in this case, a very traditional fabrication deliverable. This is exactly how the people on their shop floor use the miter saw. These are the cuts they want, so we automate the production of thousands of tiles to create, this is sort of high tech meets very low tech. And it's kind of this beautiful relationship where the deliverable is tailored exactly to the people or machines making it, and assembled in a week. And so the reason we do these experiments, we hope it's not another decade. We're already seeing exponential, gains in these production technologies. But how do we apply this? How do we manufacture buildings? How do we move this at scale? And of course, CLT timber is a material that we love. We keep going for it. We're finally doing some buildings in it. We had to move out of New York a little bit to do that. But this idea as a manufactured good, besides all of this, obviously, environmental and warmth, it's a beautiful material. It feels great. It's healthy, but it's really a machined good, and it's a material that we know we can move our design models directly into manufacturing. So CLT for sure, and then of course modular construction is of particular interest to us. It's been a while, but we did the 32-story, we call it B2, Building 2, 461 Dean Street tower in Brooklyn next to Barclays Center. And in many ways, this is it's a project where it starts with all of the don'ts in modular, which is there should be repetition, don't change the chassis types, try to keep it as regular as possible. 30 seconds. So this is, we built the chassis, a fully finished mod with the facade on installed. There are, I think, 950 units, chassis in it. I think 350 of them were different, so that is a huge no-no in the world of modular. But in many ways, and I'm sure there'll be some questions or follow-up afterwards of any issues that were with the project, but in so many technical ways, it's an incredible success that we can't ignore. The complexity, and in many ways, to start with a building block this challenging has sort of reaffirmed to us that this off-site prefab manufactured approach can deliver incredibly high quality, great affordable architecture, and it is about process and understanding process and how that, if you can control that and you understand the future ways of building, this is an incredibly promising move towards the future of construction and design. So that is it. Thank you.
Good evening. That was fantastic, John. Amazing. So many similarities to what we're trying to do too. Just you're at a little bit bigger scale than what I'm going to show you today. I'm going to start with maybe just a minute on life before Katerra for me. So as mentioned, I was at Miller Hull for about 30 years and had the great fortune to work on some wonderful projects, some GSA design excellence projects, and U.S. embassies, 5-year IDIQ, and this little speculative office building, core and shell, for the Bullitt Foundation in Seattle. And how many people in the room here know anything about the Bullitt Center? Are you familiar with it or seen it? Quite a few hands. So that's exactly the point of this project. So when Dennis Hayes set out to do this, he was not interested in just putting together a market rate 50,000 square foot office building to move his office into. He wanted to change the conversation for how office buildings are being designed and built. And I think he was pretty successful. And at Katerra, that's what we're trying to do, is change the conversation about the way that buildings are delivered. So in January of 2016, I left Miller Hull and joined Katerra. I was employee number 40, and there were 4 of us, and we were assigned to start up a design office. At that point, the company was primarily supply chain, and so 4 of us opened a design firm in Seattle. Here we are about 2.5 years later, and we're a little over 5,000 people worldwide. But what's most interesting, I think, about this is that the leaders of our company, with very few exceptions, are coming from outside of the industry. And this is that Silicon Valley disruption that you've seen happen in other industries. And it's been super interesting to be part of this and to see, a fresh perspective inserted into design and construction. So we are funded by venture capital, of about $1.2 billion of venture capital, again, Silicon Valley based. And the idea here is coming from our founder, Michael Marks, who ran a company called Flextronics. It was a manufacturing company, and he made consumer electronics. And when he left Flextronics, he had built that company up to be about a $20 billion in revenue company a year. And he had over 300,000 employees, and he had factories in 30 countries. So that's the mindset that he brings to design and construction. He sees this massive opportunity. And he's recognized in Silicon Valley as being a visionary for vertical integration. That's the thing that he really brought to the consumer electronics world. He was making phones and laptops and printers and things like that, but he did it in a way that to build Flextronics up to become number 2 in the world by vertical integration. So that's what he's brought to Katerra. We are trying to provide everything from the architecture, engineering, to the off-site fabrication, the supply chain, and the final field assembly. To do that, we've adopted, again, lessons from the consumer electronics world, where we know that logistics costs are extremely important to the bottom line of everything that we produce. So we have had to spread our reach out across the country. So through acquisitions, we now have design offices across the country, and we're now building factories across the country as well. We have one factory in Phoenix that's in operation. We have 2 in construction right now, and 2 more slated for the next year. So over the next 24 months or so, you'll see a much broader spread of our capability across the country. We're also spread out across the globe, primarily in sourcing of our supply chain. So we're going right to the factory floor for as many of the components as we can that fit into the market sectors that we're trying to serve. So we have a pretty robust team of sourcing managers across Asia and into Mexico. We have also acquired some companies in Asia to do off-site manufacturing there, and we're starting to develop market rate housing and workforce housing throughout India and in the UAE. And the sectors that we're after initially in the U.S. we started with multifamily because that was our launch customer. The Wolf Company was a developer that was part of the launch of Katerra, and they were willing to take a massive risk and a big chance with us. And they were frustrated with the way that buildings were being done, prices going up, no skilled labor, projects behind, terrible quality control, all the things that we're all faced with every day as architects and builders. And so they came to Michael Marks and said, you know, we want in on this vision, and we will give you our entire pipeline of multifamily projects over the next year and a half. So we had a pipeline of about 5,000 units. So that was enough to launch into the design and construction of our first factory in Phoenix. So most of our work to date has been in the multifamily market. You can see in this image, though, over in India, we do have capabilities to do larger projects with precast concrete. So you see some very large buildings. Upper right is a mass timber project that we have going mid-rise. But the majority of our work has been market sector multifamily. And we're doing that primarily out of the factory in Phoenix. So photograph on the left, where we have a component factory with walls and floor trusses, doors, countertops, windows, things like that. We have 2 other factories like that, but much more optimized and more automated that are coming online, one in Texas and one in Tracy, California. And the Tracy, California factory should open in a couple of months. It's about 600,000 square feet, so over twice the size of Phoenix. Texas will be about the same, and then we'll slowly move to the east. In the middle photograph, you see the press. It's a 12-foot by 60-foot press for our CLT factory in Spokane Valley, and we're just starting to push wood through that factory. In fact, just this week, which is pretty exciting. So our first panels will come out of that press and into our first building in July of this year. And then precast, it's interesting, through acquisition in India, kind of an opportunistic acquisition, we ended up in the precast business. And this is the way things are built throughout India and throughout much of Asia. And what's been really surprising is how good they are at precast. I mean, more sophisticated than just about anything you see across America. You have to go to Central Europe and Northern Europe to see facilities that are as advanced as they have in India, of all places. So it was really surprising that we were able to find a company like that there. They're at the top of their game, and so now we're really building a lot of projects in India and plan to take some of that technology and bring it to the U.S. So currently, a lot of our work has been wood frame out of Phoenix, but we're quickly moving to cold form steel. We would like to see cold form steel framing at the same price as wood framing, just because of the accuracy and the amount of space that you save in your factory and temperature control issues and a lot of other reasons why we'd like to push in that direction. Now, at the same time, we're huge supporters of the mass timber movement for a lot of the environmental reasons, so you may think that's a bit of a contrast, but what we're trying to do is make decisions with every building material that we need in order to construct in a very smart way and with the lowest amount of waste as possible. And when you get into a factory environment and you're building with wood studs, believe me, there is a lot of waste. It's very difficult to build with very accurate equipment when you've got a material that is not very accurate to start with. Now, the exception to that, of course, is mass timber. As John mentioned, this is a very, very accurate material that's made in a controlled environment, 1 or 2 millimeter difference in a 12 by 60 panel, so it's absolutely perfect for what we're trying to do. And then, of course, precast concrete. So in the multifamily sector, what we're doing also is applying the rules of and lessons learned from other industries, for example, in the automobile industry. So if you're picking out a variety of packages, interior packages or features in a car as you're shopping for a car, you know for sure that when that car is delivered to you that it's going to look great because every option has been dialed in by the automobile company, and they know that whatever you pick, they can stand behind it. And that just doesn't happen in architecture. So what we're trying to do is by narrowing our supply chain to a point where we only have a catalog of materials that we embrace, that they've passed the test for sustainability, and they've passed the test for beauty, then that becomes our catalog, and no matter what combination that a client or customer is looking for, we'll be able to assemble that and provide a real high quality product in the end. And if there are some products that we can't find exactly what we're looking for at the right price, then we will design those ourselves. So we're designing our own set of plumbing fixtures. We've got an appliance line coming out, light fixtures, door hardware, anything that you really come in contact with as a customer, we want to completely control the aesthetic of that and build all of those systems around the same idea of this kit of parts. So very few parts assembled in different ways to create beautiful architecture. The result is we want to be able to provide workforce housing it's that 80 to 120% AMI workforce housing that is largely ignored by the AEC industry, and we want to provide a super high quality product at or below the market costs. So these are some images of some of our market rate housing. And in order to do this in a way that is repeatable but still provides enough variety, this is a little kind of a dumb animation, but just to prove a point of a simple 3-story garden walk-up apartment building. So 15 million people across America live in this type of building, this 3-story walk-up. And again, it's one of these building types that's been woefully neglected by the AEC industry. You don't see a lot of great architecture out there, and we want to change that. But to do it and to have it repeatable, what you saw was 4 chassis that we have available. You can combine those in different ways. You can have different roofs to put on. But when you break it down inside the unit, those kitchens and those baths are exactly the same between unit and between one unit to another. And we're detailing that all the way down to the bill of materials, just as John was explaining in more of a bespoke project. We're doing that in a way that can then go into our catalog and become a repeatable product to use over and over again. What's interesting is you take these 4 chassis, and those are completely dialed to a bill of materials ready to go to the factory floor, but you can skin those in a way that if it's in the Pacific Northwest, you might have an architecture that looks one way, or it might in the desert Southwest, it would look different. But 90% of those buildings are exactly the same. And then you have a variety of finishes available on the inside. And as we develop this kit of parts, we can then modify that over time in order to look at shifting of blocks and different stories from 1, 2, 3, or 4 stories and so on. This product is the one that I'm most excited about. This is our workforce housing product, and it'll roll out of our factory 3rd quarter of this year. And this is that 80 to 120% AMI target we're looking for. So workforce housing, virtually anywhere in the country with no subsidy, that's our target. And that's, one of the main reasons I'm at Katerra. To do that, we're dialing, again, every panel down to the bare minimum that's required. We have 4 different structural tiers and a wide range of environmental tiers across the country, and it's taken down to a bill of materials. And then I'll end with just a little bit on mass timber, another one of my personal passions and something that I'm really excited about, our investment in Katerra. So we're building a plant right now in Spokane Valley. This is a Michael Green project. Michael Green is now part of Katerra. And we're trying to build a kit of parts around mass timber that's designed specifically for our factory. So instead of just taking a bespoke project from anyone and trying to fit someone else's geometry to, build panels for that. Instead, we're looking at how can we build a building system, say for commercial office, that is completely built around our 12-foot by 60-foot press, so that every time we use that press with 2 5-layer panels for floors in it, we're using every square inch of fiber when we do it. And that's how we're going to drive the cost of the product down, and that's how we're going to go head-to-head with concrete and steel and be able to put this material across the country, which is super exciting to me. So we're well underway in developing this product. These are some studies that we have right now underway. This is actually a building that we designed with Michael Green, using a lot of that same system that we're talking about. So in parallel, we're working on projects and product. That building is under construction right now in Spokane. The first panels out of our factory are going to be going to that. These are some rib panels that we're having tested. These panels are down at Oregon State University, and they're being tested all the way to failure. So a 50,000-pound load put on these panels to see them fail. I wish I was at Oregon State right now. I think that would be a pretty amazing thing to see. This is a full bay of that building in our factory in Spokane. So I'll close with just a couple of thoughts. A couple of the reasons why Katerra was formed. One is just this industry that we're all part of, since World War II, has the lowest increase in productivity of any market sector or any industry across the world, even lower than mining, which is really embarrassing as an architect to have to say that. It's been dead flat since World War II. So it's time for us to do something about productivity. Second thing is opportunity. There's no one in this market that has any kind of market share. Compare that to any other industry in the world, and it's kind of phenomenal. So there's great opportunity in both of those cases. For me personally, the ability or opportunity to think about changing the paradigm for workforce housing in America is something that's super exciting to me, even if it requires like a repeatable product. And then secondly, on the mass timber side, I really feel like this is one of the few things we can do to perhaps move the dial on climate change. And it's going to require something like this, but done at scale, like a really, really big scale. And I'm hoping that we're successful with that. So thank you.
Fantastic, thank you. Wow, we're getting bigger and bigger, but now we're going to maybe get a little bit more stealthy, a little bit more trickster-like. And I'd like to kind of tackle this question of can we even how do we decarbonize housing, and how do we do it? How do we do it in a kind of an everyday manner? Can that be done? I'd like to put those questions on the table. And I'm going to do that through the perspective of 3 projects, which I've selected to be kind of super provocative. So I really hope you'll throw tomatoes our way in the panel, and that this will kind of get you going. So thank you to my colleagues at KVA who've contributed to these projects. And I want to kind of start by, this quote from the series here kind of piqued my interest. And I read it and I'm like, wow, are we talking about today, or are we talking about 40 years ago? The construction industry is one of the latest to be disrupted by new technologies in Silicon Valley. Aha, so it is today. Including proprietary software, yes, another clue, an influx of private capital, and an emphasis on assembly line precision and production, I would say. So I said to myself, where have I heard this quote before, you know? And I started like flipping through the pages of my books, and I kept seeing the same kinds of things, right? Unitary production, centralization of facilities, assembly line production, automation, but exactly as was just said, this was really the time of the 1950s after World War II construction. So two big questions. How do we or can we decarbonize housing? How do we think about a future where, for sure, the cost of power and electricity will be far more expensive than it is today, at least for a while? And when material resources might be quite scarce, how do we begin to kind of even think and plan as architects for housing in that kind of condition? I don't pretend to know the answers to that, but I want to put that on the table along with how is the moment now differentiated from that moment right after World War II? What would be the differentiators? Because we know that those modern principles of centralization and assembly line production and precision did not resolve the housing crisis, certainly in the world and not in the United States, but it did contribute to a lot of carbon emissions, and it did really participate substantially in creating the kind of climate change kind of crisis that we find ourselves in now. So the first project I want to talk about is called the Soft House. It's a project in Germany, in Hamburg, Germany. It was done as a co-development in competition with Patrizia, who's a very large German real estate developer, my company, and the EBA program. So this is a federally sponsored program which has a long history in Germany, dating to the 1920s, where architects compete and in a competition, and the prize is actually winning your project and being forced to build it. So EBA had a challenge, this particular EBA that I was involved with, which was to kind of look again at sustainable construction and to really think about how sustainable living could be branded and could be made more desirable. So we did a couple of things on this project. The first thing that we did is we really tried to think much more about embodied energy and not operational energy, and all of housing is geared today towards operational energy, which is the legal energy that when you walk in the front door of your house and you open that door, that's when the bills turn on lights, that's when your electricity meter starts whirling, and that's your operational energy. But if we think about embodied energy, it's really all of the material that goes into transport, extraction of materials, bringing it into your place of production, getting it out of your place of production, and also what happens at the end of life. So this was a project where we wanted to produce energy in this house. So instead of using silicon, ingots of silicon, we went to a flexible photovoltaic system that was dynamic, working with our partner on this project, Jan Nippers, from Nippers Helbig Advanced Engineering. So Jan developed this system of flexible photovoltaics that could twist. And the Soft House is really kind of super dumb. It's a podium that's work-live, so we're sort of changing and expanding the program of architecture so that you can kind of work there, or you could rent the lower podium as a kind of a for-rent element into your house. And then we're using those photovoltaic strips, a little bit like sunflowers, to kind of begin to turn from the east to the west. And when we do that, we render those materials much more efficient. And since they're roll-to-roll, actually much like Flextronics, you don't have the high carbon footprint that you would have with a silicone-based polycrystalline or amorphous silicon solar system. So this is a Soft House. Long story short, we designed it and fabricated it in just a little bit over a year with 3 new innovations: the twisters that you just saw, the chassis itself, which is a particular kind of solid wood construction, and then the lighting system within, which is an ambient LED system. We used actually a solid wood construction too, but for many reasons that we can go into later, we didn't want to go centralized. And if I were to rethink that, I would probably advocate for a hybrid local and centralized skill set and kind of microeconomy. But we used a very ancient German tradition of Brettstapfel, which is a completely Solid wood construction. You can see here it's fastened by hardwood dowels into fast-growing softwood. No hardware, no glue, nothing. So it comes apart very cleanly end of life. We worked with Marc Holzbau, a small company, really a carpenter company. This is a skill set that's all around Hamburg in that area. And these are the 4 units. They were driven a short distance to the site, popped up. We used a Serge Ferrari weather sheet vapor barrier, which you can see here in green. We used sheep wool, and then we used a kind of larch exterior cladding, which is pretty typical in that region. So the twisters tighten up in case of storm. They become even more taut, and they provide power for a lot of things. They provide power for the ambient lighting, for some pumps that we have in a radiant heating and cooling system, and for a last mile solution, for an e-car. And so I want to go inside the house for a minute and say that in order to kind of realize this, we had to really reconceive of the interior of the house. We had to strip it bare. We had to kind of really imagine a very different aesthetic that was like almost 100% wood, and then just this one curtain, which became a kind of important actor and animator of the space, a curtain which contained the ambient lighting that you could move back and forth. And as you moved it back and forth, you could actually kind of create these little micro rooms, these zip rooms, we call them, that could have different kinds of levels of heating and cooling. We worked with a consortium of manufacturers to realize this, and this is a video from Swedish television, actually. We didn't design the birdhouse. But they brought a crew in, and it's kind of weird when you're making an experimental house. The units are all sold, they're all occupied, but of course, we don't know these owners. We don't know them personally because this house is, a real estate development. It's for spec. But you can see the way in which these people are using the curtains and how they kind of move from kind of more conventional room dividers, everything that you would expect a curtain to do, to beginning to kind of contain this ambient light and moving from a kind of flat window to a more figural condition. So just the point I would make on this project is we tried, and through the aegis of IBA and the Federal Republic of Germany, to kind of produce this zone of skill set around a certain pocket of forestry in the north of Germany. There's also another one that we also related to, but we were quite nationalistic, and I think if we were going to do it again, I would look at something like short sea shipping with a fabrication facility like that of the former thin forest for plywood. And you would begin to look at how the biodiversity of where timber is could produce a different kind of culture of construction that would be transnational in Europe and would kind of introduce a kind of trade zones that are not necessarily nationalistic but have more to do with the biodiversity and types of wood that are available. If the soft house was kind of a hybrid of high tech and low tech with the new technologies and the active version of the passive house, the Chrysanthemum Building is extremely dumb and extremely low tech, but I do think it's a kind of a viable potential strategy. I love this advertisement. It's from the Sackett Company, and it's showing a person drywalling a wood stud wall. And the idea was that U.S. Gypsum in the day wanted to incorporate the wall, wanted to take over all the materials and make a kind of single vertically integrated wall that they could sell. And I think that the wood stud, the dumb wood stud, stick-based construction that often is vilified still may have a role in the kind of decarbonization of architecture. And that role might have to do with these really funky sites that exist in cities, because so much of our cities are already built, and we have these very odd geometries and these very odd infill conditions. And actually, if you leverage the workability of stick construction and the fact that it's not repeated, and then combine it with some panels that are repeated, I think you can do some pretty interesting things. So the first way that we transformed the wood stud was to actually resource it, right? We changed the sourcing location and got that from some small pockets of forestry in Massachusetts that was brought into Boston. And then the second thing we did was create some new technical details that allowed us to take things like the elevator shaft, party wall condition, and so forth, and make that all out of wood. And we got that passed by the inspector. So the city, produces this kind of funky geometry, and we try to leverage that to take advantage of the kind of flexibility and workability that the 2x4s have. All the waste goes to Re-Energy, which is actually right next door to our office, KVA, and they make wood pellets for stoves up in Maine, so it's kind of a full cycle economy. And I'll show you this in a minute, but we use the kind of smaller spaces up front for a bunch of micro units, quite small, and then we have what we call an adaptable family loft in the back, which I'll show you in a minute. So it's a very impacted urban condition, Chrysanthemum Building. This is the render, if you will. This is what the building is like now. It has a lot of pressure, being in a very old, fabric-y kind of part of Boston. And this actually was market rate housing. We were able to build this for a very, very reasonable fee, which we can discuss in the questions and answers. But you're going to see here, right, that there's still a steel podium because this is a mixed-use commercial. So we're still accepting that steel because we need that as a fire stop. But all the floors above, all that's wood construction. You'll see the guys carrying some plywood there. And looking right back in, you're looking through the micro units through to the adaptable family lofts. So what's kind of interesting about this is, let me go back one, is that we are able to kind of think about core and shell in this balloon frame construction. So it's a very dumb construction, but what you see there in orange is kind of like a deliberate churn strategy that's made all out of forest certified wood, so that you can set up your unit and enjoy it for 10 years, and then you can take that plywood out and recycle it and put in a new interior. So we have a lot of storage, we have composting, we have a lot of services in this. And in the larger adaptable loft units, we just do something very dumb, which is to say, why have different unit plans when one unit plan can be adapted over time, right? So someone could have a small office, work at home office, cut down on commuting, or a small bedroom. You can have 3 bedrooms, or you can pop in a stair here and connect units. So this was sort of a technical project, but it was also very much an aesthetic project. How does that, churn kind of use of wood, the plywood lining, how does that transform things? What about vintage reusing? This is a Walmart's table that they've actually just put a plywood top on. And because this was a little bit more money than it would have been had we not used the forest certified materials, our developer did a very, I think, interesting thing with us, developing an app called the Chrysanthemum Building. And really what it was is an aggregator app that's sold to residents, and all the units are sold, as a kind of aftermarket way of recouping money. It's sort of a profit center for the developer. And it just aggregates all of the different services that are in the walk zone, like, for example, of slow food, farmers markets, the bus schedule, the dry cleaner, and so forth, and brings that all together as a service. And then it also performs composting services for the Boston residences, because the city of Boston doesn't provide that. It's not like San Francisco. So it's a way of kind of supplementing some of the building management services. That's the Chrysanthemum Building looking the other way. The last project I want to talk about is, I'm also being, I think, quite provocative with it. It's called Plant Properties, which is supposed to be a little bit of a play on words. It's a joke. And this is a future urban development. It's also an ongoing experiment that I'm working on with my colleague, Michael Cerone at MIT. He's a chemical engineer, I'm an architect, and we have a mixed team of students who've been working on this. And we know that plants repair themselves. We know that they're amazingly efficient. There's nothing that we have on Earth that's as efficient at creating energy, at getting its own water, at responding to different chemical signals. I mean, plants are really a biological platform for technology. And so in a field that Michael's team is developing called plant nanobionics, he's looking at nanoscale particles as applied to the biology of plants. And we are experimenting with a process which allows plants to produce light. So in this future, which is not so far distant from our present, plants would provide oxygen, they would help clean water, they would provide nutrition, and they would also produce light. The light is very dim. This is a spinach leaf, and you can barely kind of read the words. So this is a crazy, out there idea. And you might ask, well, why are we doing this? Do we not have anything better to do, more pressing? But when you look at this Skenke graph, this is from Leon Glucksmann, a venerable expert at MIT, it doesn't really matter where you start on the fuel side, right? You can pick your fuel of choice. By the time you get to the lighting in your home, there's been a tremendous amount of waste, like over 90% waste. So you're only getting a tiny, tiny bit of efficiency from that electric grid system. I think in housing, it's time that we move on from the electrical grid system altogether. And it's not about a plant replacing your desk lamp. It's about the potential of a plant to replace, to not generate the footprint of anything that has to do with the electrical grid. No battery, no nothing. It's all natural resources. So actually, give credit to the CooperHewitt. They took on our project, which is quite a challenging experiment because it's introducing living plants, and it's an ongoing experiment that you can see in the museum. It's always difficult to bring plants into a museum because plants have insects and plants have moisture and they have many things that are difficult for museum collections. But what we did is imagine a kind of a typical New York City tenement, and we designed a light harvesting system, which I'll talk about, a water distribution system. And you can go and take a look in some of these little peepholes. And when you look in those peepholes, you can also take a photo and upload it to Instagram at Plant Properties. Many people have done that. But you can begin to understand what life might be like in this future when perhaps plants actually provide a domestic infrastructure. So for example, this is WaterShare. This is a way in which people and plants are sharing the same water. So bathrooms are much more luxurious. They're covered with plants. The illumination is happening there. The water system that is providing a gravity-driven, right? This is not grow lights. This is not like a cannabis factory or an indoor farm, right? In this world that we're imagining, we're quite resource constrained. There might be some electricity, but there might not be a lot. So we're using all natural forces, gravity, sunlight, water, soil to grow these plants. Here's my colleague Daniel, actually with a system that's inside at the museum. This is a light harvesting system that takes the light and directs it to the plants that they can grow. And we're experimenting with various different kinds of systems. It's quite fascinating. This is the Citizens Plant Lab. Some of these peepholes are not dark. You look in and it's sort of exceptionally bright. It's full of sunlight. And there are some people, and we're being very deliberate about having the people be completely abstract, right? You don't need to be an architect to know that that's not a real person inside there. But everything else is real. All the resources are real. The plants are real, their light is real, the sunlight is real, the water is real. And the light of the plant is scaled a little bit because the room is at scale. So anyway, you can see the process of infusion. Here is a scientist beginning to infuse a plant with the nanoparticles. This is a lot like what happens at the lab. It's a pretty gentle process of infusion. The nanoparticles become part of the plant, and they take up some of the plant's stored and renewable chemical energy, and they convert that energy to visible light. So that leaf, for example, becomes that, becomes this. And we're working now on changing the infusion method, thinking about things like sprays and irrigation, so that this could be applied to larger structures and be repeated. The light could last longer and be brighter. Right now, it lasts in a matter of hours, but Michael's mathematical model suggests that this could last days and even weeks. This is the plant party. This is a kind of a new kind of socialization that begins to happen in this world where people bring their plants, they compost together, they have a kind of whole recycling kind of economy within the building. This is the library, the place where they read by plant light. And this is the last image that I have. So I just want to just kind of sum up the kind of strategies here that I'm just touching on. That there can be hybridization, right, with the soft house of kind of distributed and centralized methods of production. You can have plywood that could come from a Finn Forest-like company, but you can also have Brettstapfel that builds kind of local labor in neighborhoods and regions. You can also hack existing systems of construction to kind of resource them differently and to expand what they can do, as with the Chrysanthemum Building. And you can also understand that the living biological technology that a plant is can offer us a wholly different way to think about domestic infrastructure in the future. Thank you.
Hello, everybody. Every presentation was fascinating. So I have a number of questions, but I know the audience has questions too. And we have about half an hour. So I'll just get right to it. I think my first question is a hard one about scale and replication. So all of these are amazing, and we currently have an affordability crisis and an environmental crisis. And you all showed us ways forward in reducing our carbon footprint or providing more middle-income housing. And I just looked back sort of in history, just 65 or so years ago, to Lakewood, which is a subdivision in California, and just brought the numbers forward. So it was 17,000 units constructed in about 1,000 days for a sales price of about $8,000. So if we adjusted for inflation, that's about $140,000. And it is an average of about $120 a square foot. So I guess my question is, when are we going to get to the point where we could build a Lakewood that's energy efficient, but also sort of broadly accessible? And is that just architecture and construction, or are those policy changes also that have to overlay on that?
All of the above. I think there's, to paraphrase Langdon Winner, who posed the question very famously, do artifacts have politics? And then answered in the affirmative, yes, they do. He said that all the choices that we make for the stuff around us, clothes, buildings, cities, impact our choice of political life, political and social life. So I think that we will arrive at a point where there won't be a question that we will be able to do that, because we will need to be able to do that. I think this is going to be needs-driven, and I think things like carbon tax, New Green Deal, and other things that are out there as proposed legislation may be the kind of first steps on the policy side.
Yeah, and is this on? Yes. Okay, thanks. Honestly, I think part of it also is just material prices, lack of skilled labor, fewer people, going into the trades. There's so many things that add up to the current problem that we have now. I don't think it's anything necessarily. You can't put your finger on any one thing, but I mean, that's the kind of study that we find ourselves looking at all the time at Katerra, and trying to almost reverse engineer a Sears house or the Usonian house or this example, right? I mean, this is something that architects have worked on pretty hard for a long time. And honestly, part of it, I think, also is putting together a system of factories and supply chain that have that economy of scale built into them. If you have a factory and you're producing one or two buildings and then waiting for the phone to ring, that product is not economical. You have to have an automobile factory has to be producing full tilt 2 shifts, almost 24/7 in order to produce at a rate that people are expecting. And so we sort of need to change the way that we do things in a way that becomes more like other manufacturing processes, I think, in order to get back to that.
Yeah, I would just add, we do disruption. We see happening. We do think it's inevitable in terms of process and the way that we deliver. And it's going to take retooling of contractual models. This idea of a design, bid, build, where everything is very serial. There's just an incredible amount of waste, of effort, of energy, and you see contingencies piled on contingencies, and there's all of these approaches are incredibly necessary, and the material science behind new ways to harvest how we make our buildings when that meets the standard of care that we're able to digitally realize and execute a building with no waste, the most efficient way possible, all of that will inevitably drive, you know, a huge shift in how we cost the making of buildings.
Unless we can grow them.
Unless we can grow them. I mean,
And John, you talked about CLT, and I heard in that that you had to move out of New York for, at least for one of those projects. Could you talk a little bit about some of the hindrances to some of the more innovative or new materials that you want to?
Yeah, no, I mean, you know, a few years ago, we had won a competition to do, you know, from the Forestry Society or Institute to do a mid-rise building in Manhattan on West 18th Street, and we had a 12-story design, which we felt was beautiful. It was, you know, the client was incredibly engaged and excited in the idea of these kinds of environments that New Yorkers could live in, and it passed fire testing. You know, they sponsored all of the performance requirements was met. Performance requirements were met. You know, even the fire commission had stood by the performance criteria, and at the end of the day, you know, the concrete unions and there's a huge opposition to it. You know, the codes are changing. We're seeing it happening. You know, we're working on a project in Toronto where we're able to do a larger scale CLT project, but it's inevitable, and so we keep promoting it. We promote it at all of our master plans. We show in a sense that when we're using kind of automation, there's rules. In a master planning scale, the idea that we could take a plot and quickly devise a strategy, a structural strategy, we always kind of default to mass timber as our unit of measure.
And then maybe related to that, Craig, when you showed your factory in Phoenix, I believe it is, I was thinking about the plumbers, you know, the cabinet makers, and others who might be some of those entrenched interests, but also some of those middle-class jobs that we might lose in getting efficient and also reducing housing costs. And I'm just wondering if in your thinking about sort of how Katerra progresses, how those trades, and in a place like Phoenix, a large part of the economy, which is driven by sort of the small contractor, the sub, and construction, sort of play into your business model.
Yeah, we've seen some pretty interesting conversations. Our Menlo Park headquarters, quite often when I go down for meetings, there is a sign at the bottom of the road, 4x8 sheet of plywood, something in a picture of the Grim Reaper, and a guy dressed like the Grim Reaper, and Katerra is bad, and that's the entrance to our headquarters quite often. It's, you know, protesting coming from the unions. Now, at the same time, we've had conversations with union leaders who have said, hey, we know we need to change. In fact, our people can't even afford a place to live. So if this is a solution for housing for America that our skilled workers need for their families, then how can we work together? So yeah, there are the people out there like the concrete union that killed that Timber Innovation Act project. The one in Portland got killed too, unfortunately, but we have to persevere. You know, those were two beautiful projects. And it will happen, and yes, we will have the protesters, but we just have to charge ahead. And it's we have a team of people who are advocacy experts, and they're meeting with union leaders, meeting with AHJs and building officials, and in order to try to just educate people of this new way of building. It'll just take a little bit of time.
AHJ.
Agency having jurisdiction. Yeah, cities, sorry.
I mean, the only thing I would add, I mean, to that too, that, you know, the unions, yes, I mean, it's a powerful force. It's something we can't ignore. But the modular project next to Barclays, that was a union job. And it was, it's 50% affordable housing. There's always extremes on either side. There's an ENR, there was an ad, a full-page ad run. It was a charred baby doll. And it says, this is what happens when you build in wood. And it's sponsored by a concrete society. But you see that, but then at the same time, the response, the ability, one of the biggest, I think, innovations that Forest City at the time, the developer, made was these relationships with unions. Similar to our, I think, political dynamic, there's a strong polarization happening, but it's not mutually exclusive, and it can work.
I will add one really interesting thing about mass timber, though. It is the only thing I've seen in state governments across the country that is pretty widely accepted by both sides of the aisle for different reasons. So you've got the environmental community on the Democratic side who are really interested in it because of the carbon story and sequestering carbon instead of emitting. But you also have, on the other hand, the Republicans are very, very excited about the fact that these mills are going into rural areas. They're bringing jobs back. And to start harvesting timber out of our national forests is something that the Republicans have been looking for a long time. And now the U.S. Forest Service is embracing that. And so they see this as a way to bring jobs back, healthier forests, cut down on fire danger. So it's really interesting. It's been a win-win for us as we go to various legislatures across the country.
But I think, it was interesting to see that I want to push back a little bit on this narrative of like ever more incorporation, ever more centralization and so forth, because I think that's the kind of modern principle that didn't serve us that well. But it was really cool seeing your network of factories that's beginning to spread. And I think if it can be more like hub and spokes, and if we can use data, for example, to scan skilled workers' cabinets and plug them into the system or whatever, I don't think we can make a centralized closed system a kind of perfect infrastructure and expect to ever really see that meet scale. Maybe it might take a tremendous amount of investment to do that, but there's also the question of sort of social acceptability. So I think the more that we can think about this as a network, because with the exception of data, and even data is distributed, a lot of kind of our biggest breakthroughs are really all about distributed technology, Zipcar, a sharing community, Airbnb, and so forth. It's not centralizing. There's not a big hotel factory that's like making hotels. We're finding them everywhere. And so I think that trick, that breakthrough would be to think about how housing can become like a little bit stealthy and deaf that way.
Also on that, Sheila, your map of a kind of, I think you called it the polycentric
Yes.
Network, to me seems like sort of making some of those things visible could be maybe a counter to some of those entrenched interests to show how that supply chain works. And I was just wondering, that was for a European context, but if you had looked at it in an American context for a particular either typologies or products.
We've looked at it in a couple of states, Massachusetts obviously, but also Arkansas, where there's been an interest in timber, mass timber, because of the forests that are in Arkansas, and also the desire for people to kind of get the workforce out there and grow a kind of in-state economy. But I think it would be really fascinating. Our office is what? Like it's 16 people, so we're not 15,000 people working globally. So I'm sort of, my presentation today was I'm guessing that many of you also are not in large global offices. And so I just wanted to kind of like put on the table that there are different strategies that we can all use. But I think it would be super fascinating to do that kind of supply chain and open-ended network diagram, for a large company or for a design firm like Shop that's doing large work, just to see how that works, because that's where all of your data and your units would really, your accounting and BIM would really be so impactful, I think. It's not so much kind of morphing through a parametric form anymore, but really quickly assessing the substitutability or the fact that perhaps a certain type of material has just run out. We've run out of sand. What do we do? How do we put in aggregate or whatever? And I think that's going to be super useful in the future. It's going to be a slight tweak on how you're describing it, but I think it's going to be useful.
So the majority of our housing is already built, and it's going to need to be renovated. And I was wondering if in your systems or in your thinking, you've thought about sort of the rehab or reconfiguration and how some of these new materials, new methods would work into that.
I'll jump in and then I'll turn it over to you. We done a couple of workplace, actually global headquarter workplace projects for a Meister group of lawyers. And there we really experimented with just what is the bare minimum that people will accept, that clients will accept, and especially lawyers will accept. And of course they started with like paneled offices and, air-on chairs and all of that. But we just stripped it down and said, this is what you're getting. You're getting this sustainable plywood. You're getting ratchet strap furniture so that you can take it down and pop it up and you can expand it when you move. And you're getting non-VOC blue paint because your logo is blue, and that's it. And it was a bit of a process, but I think stripping down our interiors is certainly one way of kind of decarbonizing, and then filling our interiors with thrift, with vintage, with thrift, with all that kind of stuff, and not the kind of plastic and petroleum products and stuff that that this room, as nice as it is filled with, and that our homes are also filled with, because all that stuff is super toxic. And there'll probably be a higher and better use for that petroleum while it lasts, like maybe in a hospital or doing other things. So we really need to radically rematerialize our built environment, both exterior and interior. And then one last word on plant properties. We thought long and hard, like, are we really going to propose a kind of New York tenement building, which is like a bit of a box, and then have this kind of life inside of it? And then we said, yeah, we're going to do that. Because so much of the future, especially a green future that involves plants, is like completely a new construction with very obedient plants that live very neatly on the roof, or that they comply perfectly or nearly perfectly to the vertical orthogonal surfaces of architecture. And the plants that we were imagining they're not genetically modified, so they're wild growing plants, and they need people to cultivate them, because if the plant dies for any reason, the light would also die, and then the person wouldn't have access to that infrastructure. So the plants become quite transgressive, in fact, to the architecture of the tenement, and areas have to be scooped out to provide light. Soil has become part of the economy, composting and things like that. So it's been quite interesting to think about a kind of radical experiment of a new domestic infrastructure and an adaptive reuse project.
I'll give you an answer that's about 180 degrees from that to the question. This is super practical, but it does deal with the fact that there is a real need for renovation of multifamily housing and honestly hospitality too. So we acquired a company called United Renovations. They're based in Texas, but they're pretty much a nationwide company. And what we discovered is that because we own our supply chain for multifamily, we could kit renovation packages depending on the level of renovation that's required, and arrange those in a way, in a sort of a factory or even warehouse setting, distribution center setting, and be able to send teams out to these projects with absolutely everything they need to do a renovation. So you could have a team of 1 or 2 people that can turn around a renovation in a matter of hours. And I mean, these guys have been at it for a long time, for decades, and they can't believe the productivity increases they've had by not having to bring in multiple trades. It's training a new type of worker, someone who can do it all. It's plumbing, electrical, installation of wall panels, bath kits, kitchen kits, kind of IKEA-like systems. But I think there's a huge opportunity there that will make it much more affordable to do those renovations. And to your point, Sheila, I think those kind of kits should be available to anyone. Just, all of our products are going to be available to anyone. So this network of manufactured assemblies, I think, is super exciting. You can buy, bath kits from, hopefully there are many companies like us in the future that are producing beautiful cabinet kits or even wall panels or floor panels that you can buy fully loaded.
So we have 2 microphones on either side. If people do have questions, please come down. And while you do that, I'll ask...
while you storm the mics.
Yes, while you storm the mics. I want to ask, all of this stuff is very new and is so much more than architecture. And I was wondering, do we need to sort of change the way we're educating architecture students, or maybe we just teach them how to collaborate. But also people already in the profession. And how do we do that for this, our new sort of burgeoning threats and crises, but also these new materials? Are you teaching differently or collaborating differently?
I mean, yes, I think it has to start at academia for sure. I mean, I think the good news, and for all the comments and conversation you have about millennials and attention spans in this, we are seeing a trend where the idea of the project as a trophy, as a singular icon, the architect as this sort of lone craftsperson, the artist that this is my vision, no matter how much concrete or trees you have to tear down and electricity and carbon we have to burn. This is my art. This is my craft. That solitary approach towards the object of architecture seems to be moving out of vogue, and the idea of the project as it situates in a network of an urban context, how it affects supply chains, and the fact that this is being taught in schools now, we're certainly seeing that in terms of the programs, but the student appetite for collaboration, for understanding the role of design outside of the building is really organically morphing for we think the better. I mean, it's great.
Do we have a question?
Hi. My question's for Sheila. It's regarding new biomaterials. Considering the carbon emissions benefits of using hempcrete, do you think that there's a possibility of it being taken seriously as a sustainable building material?
I didn't catch that. The carbon absorbing potentials of what material?
Sorry. So it's about new building materials.
Hempcrete. I think that I'm not. I don't actually know the potentials of hempcrete. But I have worked with hemp. I've worked with linen. I've worked with a number of other biomaterials, and we were talking just before the panel about a large car company that makes technology for cars in France. And they're actually really reconsidering all of the materials that are on board, and they've done a lot of testing on agricultural waste because I think there's material that's renewable like wood, like plants, and then there's trash that can be upcycled, whose value can be changed. And they're actually looking at hemp as a very significant composite material, in car interiors, because of its tensile properties, its strength, and also its lightweight properties. So I think that could be. Thanks for your question.
There seems to be an inherent conflict between the potential for distributed technologies and all the gifts that they bring to cultures and the kind of evolutionary nature of expertise and the way in which we get better at things by doing it over and over again and improving upon what we start with. I mean, there are many, many examples of that. I mean, automobiles are one. The B-2 tower is another one that really didn't hit its stride until much later in the game, and as people learned how to take advantage of the system that was presented and solve some of the problems. So we have this issue, and I'd love to know your perspective on it, how you leverage expertise, perhaps without becoming so involved in this corporatization or this huge scalar operation, and simultaneously keep the advantages of a distributed technology where the kind of vital and experimental nature of society keeps rolling. So where do we go with that?
I think that's a fantastic question. We're finding that surprisingly difficult to come up with a design for what seems like the simplest building and to really be able to produce it in a way that can be repeatable, because we don't have that experience yet of doing it over and over. Like, the building you do one, and then you really want to do another one. You want to learn from each one you do. So we're starting to do that now we've hired a firm that is out, and they're literally a team of people with clipboards and stopwatches, and they're on our construction sites and watching how long it takes people to do certain tasks. And it's like lean, or what's it called, like Toyota, where they're trying to shave seconds off of the production of an automobile. I think this industry just hasn't seen that kind of repetition and learned from it, and we're trying to get there, but I think it's going to take some time.
We could also acknowledge, I think that's a great answer. I think I would just add to it that we can acknowledge two types of expertise, or different types of expertise, all in the purview of the architect. One is the kind of expertise that does benefit from doing things again and again, right? That benefits from being repetitive, and the other is got to be completely different, right? Very left brain, because that kind of expertise would be the sort of expertise that asks the important questions and actually defines what the problems are, right? So somehow or another, in our education and in our professional lives as architects, we need to find ways to exercise, both sides of that expertise. And I would include in the latter the most important kind of form of expertise that I think architecture education gives us all, which is the power of the architectural imagination, which sounds like fairly trivial or even cliche to say that, but to be able to imagine something different is hugely impactful, particularly today when news is questioned and everything is scripted, and we all live within our little zones of what we do well and what we don't do well. So I think that the ability to imagine that things could be done alternatively or differently is hugely important to hang on to.
Yeah, just the last thing I would add to that is how important in all of this technology and automation, that human relationships. I mean, it works. On Barclays Center, the relationship we had with the project managers running the factory floor. We didn't own those factories, the machines. We don't dictate what machines they purchase, and the sort of evolution of how that communication, that trust. If one of those cut files is wrong, the trust falls. It's buried, and it's a massive failure. But you see the exponential scale at which people are engaged and willing to produce and excited about a new process, and it is contagious. We experienced that again in Cape Town, South Africa, with a totally different group of people with different mentality and different. They have a less litigious group. They were more excited about, what is the fastest way we can do this, and we linked into their database. We didn't control their systems machines. We worked directly with them, and the excitement and engagement that happens, the more we can sort of continue this, and not we as shop, we as an industry and a profession, to kind of unlock the efficiencies in this. It is exciting, and it is a path forwards that ties that sort of tech, cold, autonomous, with the human desire to be relevant and make and work.
So just being aware of the time, I want to thank our panel. I want to thank Rosalie, Emily, and the Architectural League, and you for coming out tonight.